that going to be on the GoFundMe?
See, this is what happens when things break on robots. You must do immediate surgery. These are our tools. Scalpel. Blood bucket. Next patient.
This video was made to document the story of the CNM SwarmTeam team. We have gone through many trials and tribulations working with these robots, but where to begin? Maybe with, what is the Swarmathon? The Swarmathon is a robotics competition held by NASA to design robots using the theory and fundamentals of swarm dynamics. Swarm dynamics is a big word for many robots doing the same job, like an ant colony. Each robot will be doing the same task, but working as a whole to achieve them. The competition is based around small robots called swarmies. They were made and distributed by NASA to very select colleges to build algorithms, write code, and develop new ways to search for key items or targets. The end result is to build upon this code for resource gathering in a planned mission to Mars. We have been given the privilege to help develop the foundations of which this project will be based. So how difficult was something like this? Well, let's meet some of the CNM ST team and find out.
Jarrett?
What do you do?
Huh?
What do you do?
Program.
Program. You're studying at what school?
Central New Mexico Community College.
Name. What do you do? That's not what you do. Try again.
Have fun. Have fun at school.
What are you studying at school?
Studying computer programming and robotics for now.
Well, what school do you go to?
Central New Mexico Community College.
Rebecca.
What are you studying?
I'm studying cloud technology.
What school do you go to?
CNM.
My name is Jeff Schlindwine.
What do you do?
I program and hope to get into robotics.
What are you studying in school right now?
Programming.
Great.
What school did I go to? Central New Mexico Community College.
Hey, I already answered that one.
What's been the biggest challenge in this Swarmy project so far for you?
For me, biggest challenge. Well, it'd probably have to be a tie between the lack of commenting in their code, so actually learning to understand the code that was given to us to start out with, and that and localization.
What was the most challenging part?
Going through and actually figuring out the code. Because the code was really not commented in a very helpful way for me or anybody else on this team to really understand, having zero idea what ROS was, how ROS works, the ROS libraries, the ROS calls, publishers and subscribers, timers, all this other nonsense. None of us had any idea how that worked. We spent a good month and a half of the entire time learning just what the code was doing originally. And that was probably the hardest and most challenging part, was going through the code and actually figuring out what it was doing originally. The code? So if these robots were programmed when we got them, what did we do? Well, the code was a very basic implementation using ROS libraries, or a robotics operating system. In short, it controls many aspects of robots and is the future for robotics designers, both professional and hobbyist alike. In the basic code we were given, the robot was searching randomly and not really doing much of anything, as we later found out. We had to make it better, and we did, but none of this was without its problems.
That didn't work.
Let's talk about just that, our troubles and how we overcame them. Let's start with the biggest one, the code. I won't make this a supremely technical topic, but I have to go over some basic principles so you can understand what the issue was. When given the swarmies, we faced a monumental challenge of manipulating them to compete. We eagerly dug into the code to find a bunch of code we had never seen before, concepts and designs that we had no experience with. It would be like someone handing you 14 pages of documents written in a foreign language that you had never seen before, and you were expected to have it analyzed within a few months. We had to learn all new functions and programming principles on top of our current knowledge base just to wrap our heads around what was originally programmed. Like with anything, you have to know what something is doing before you can go about fixing it, to alter its behavior. Once we started to grasp the code, and commented, and presented to the group what everything was doing, things began to come together. It started simply with getting the robot to do basic tasks, such as spinning in circles and going in a straight line. This was a crucial step in understanding how the robot was figuring out where it needed to go. Once we had a firm understanding, it was time to move on to the next task at hand. The competition calls for us to collect small data tags, or April tags, and return them to a center location. This is a mock resource, as it will be hopefully replaced with samples in the planned Mars mission. However, the end result will be the same: collect and return to a collection hub. This is when even more issues became glaringly apparent. Test after test after test showed us our inability to return to the center to score or store our collected April tags. Something had to be done. It escalated the importance of us finding a good search algorithm and pushed us to score. How did we do this? As you probably saw in some of the videos, we had programmed the robot to do something really simple, especially for us people. Find the center, turn completely around, and drive. We would feed it an April tag to get it to return. This wasn't working, obviously. We turned to a basic search pattern of having the robot move in squares. So, why did we pursue a square search pattern? Well, that was really easy. We wanted to move around the center circle, or collection area, and pick up tags going outwards towards our boundary. Moving in a square is also fairly simple. All you need is 4 points, and you can navigate around the arena this way. Like this. 1, 2, 3, 4. Eventually letting the square grow bigger to expand your search. Like this. 1, 2, 3, 4. After you collected a tag, you could easily use the same search pattern to refine the center if the robot couldn't locate it again. The question is, did it work? Well, in short, the algorithm was working. It would navigate in a rough square shape, but not really around the center as it should. This was because the way the swarming was calculating its position was drifting, or slowly moving. Why was it moving? Imagine if you were blindfolded and asked to navigate a maze. You might think you were going in a straight line, but in reality you'd be listing off to a direction. The swarming has a similar problem. The distance between where the swarming was in reality versus where it thought it was in its brain kept growing larger and larger. So, because of this drifting problem, we had to come up with a different solution. How did we overcome this problem? Well, the issue lay in its hardware. The sensors that kept track of where it was simply were not capable of accurately telling the robot where it was in regards to the real world. Because of the restrictions on not modifying the hardware, we had to fix the issue in our software. We instead turned to using a fixed point, one that wouldn't move and stay relatively static or stationary, to calculate the next point for the robot to drive. This meant reconfiguring the math and calculations just a little bit. In the process, we noticed the simple square pattern was simply not efficient enough, and instead moved to an octagon-styled search pattern. This gave the swarming infinitely more capabilities in finding and securing not only the tags, but also refining the center, if the robot ever lost the center's true position. If this didn't sound like a massive undertaking already, we had hundreds of other issues that kept us biting our nails and holding on, trying to stay competitive for the competition. Multiple hardware failures, like one of our robots, Alpha, having his Arduino board, the board that controls the motors, die before we could even use them, as well as a GPS device completely dying on another halfway through the semester. All of these things really knocked us down to working with just one robot. The entire time, finding technological, mechanical, and learning and calculating the math necessary to move the robots was daunting, and we were lucky some of us didn't lose all our hair. The best part of this project, however, and some of the most rewarding, was visiting and talking about STEM projects such as this to over 2,300 high school students total in our outreach activities.
Hello, what's your name?
My name is Samuel.
What is your degree?
I'm getting a degree in computer science, computer information systems with a concentration in computer programming.
What are you hoping to do with your degree?
I really want to develop mobile applications.
And what school do you go to?
I go to CNM.
And what was your biggest problem you faced in the Swarmy program?
That's a big one. I had a lot of problems actually. It wasn't just one really big one. We faced problems with the hardware itself, the software, trying to learn ROS, implementing ROS, and it was a lot, but we've made a lot of progress.
What's the biggest thing you've taken away from this program?
Gosh, that's a really big one. A lot of things actually. I've learned how to work with other people a lot more, and I've become a better programmer because of this.
Awesome. And knowing the hurdles that we've had to jump through this semester for this program, and if you were to continue helping next semester, knowing that you're planning on graduating, what would you be looking forward to most?
Really sharing my experiences and being able to help people and make sure that they don't come across the experiences I had, just making it easier for everybody else.
What is your opinion of the outreach projects that we did, and how did we do on them?
I'd say they're pretty critical. Trying to promote STEM and everything that we've done is very critical in trying to reach these high schoolers and really tell them, that there's opportunities like these that actually exist.
What was the biggest hurdle in this program so far?
Biggest hurdle?
Yeah, for the entire Swarmy project.
I don't know. The robots itself, I guess.
So what was the most difficult part for you to learn?
Debugging, like trying to get values out of the robot itself, and working with ROS.
What's the biggest thing you've been able to take away so far?
I don't know, robots are complicated.
And what are you hoping to do with your degree?
I'm not sure yet.
What would you like to do with your degree?
Work for a company that pays me a lot of money.
Glad that you have your principle of your degree in mind. Thank you.
Okay, so Jeff, what did you get out of this competition?
I got a lot. To start off simply, it reinforced my foundation for C++ programming. It made me really think of creative ways to program. I learned the ROS system, which was incredibly difficult, having no one to help you go through it. I learned to be very self-reliant as a programmer, learning how to look up function calls, learning how to do all sorts of things with programming.
So, how much programming experience did you have before this?
None.
How much programming experience have you gotten out of this?
A fair amount.
What all have you learned?
I've learned a lot. I've learned how to use a programming language to get it to do stuff. I've learned a lot about GPS that I didn't know. I didn't know what a EK, I don't even know what the acronym